Yes, sir.
Okay, okay, okay. Aniruddha is there in the meeting? Yes, okay. So, yes, did you start your recording? Okay, 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 great. So, let us recap, right, what we have seen. So, let us say that I will give only one case, L, and this is your capacitor C, R, L, C. And then I'm applying some voltage. I'm applying some voltage here, V, and due to this voltage, some current is flowing. Let that current is I. Okay, I is flowing through all the three. Okay, so when the current is flowing through the resistor, it will make voltage drop across it. Let it be VR, let it be VL across inductor, and VC across the capacitor, right? So what is V? V is nothing but the voltage is nothing but total voltage is vector addition of all the three voltages, right? So all the three voltages, how we can quantify it as VR square plus VL minus VC whole square, right? Also, we have seen that what is the impedance of the circuit, that is total resistance offered is nothing but R square plus, yes, can anyone tell, XL minus
X
XC
equal to square.
whole square, okay? And then, we have also seen that, yes, if this is nothing but your current, right? If this is nothing but your current, then we can say that voltage drop across R will be in phase, right? So let us say that this is, let us say, VR, okay? And then yes, what we can say, inductor voltage in the inductor is yes, leading the current by, let us say, 90 degrees, right? 90 degrees. So this is VL, and voltage across the capacitor, yes, lags the current by 90 degrees, right? Isn't it? VC, right? So this we have seen, isn't it? Yes, no?
Yes, sir.
And then in resonance, VL will be equal to VC, and yes, in resonance, what will happen? This VL and VC will become same, so this will cancel out with this, and your VR will be equal to the applied voltage curve. Correct? Yes, no?
Yes, sir.
Okay, okay, great. So, yes, let us continue our discussion. So, we know that, yes, now RL in series, right? What will happen if R is there and if L is there? If R and L is there in the series, what will happen? We will take, yes, yes. So, this is your current I, right? So, where will be VR? Where will be VR? In phase with the
Same phase,
current,
sir.
right? So, this is your VR. And where will be VL?
90 degree of
90
phase.
degree.
Yes, so correct. So now I think that you are perfect in phasor diagrams, right? Okay. Now let us discuss some new things, right? So let us discuss about RL. Let us discuss about RL in parallel, parallel, right? So RL in parallel means what? So let us say that this is your resistor and this is your inductor, right? Okay, this is resistor, this is inductor, okay? Now can you tell me that, let us say that I'm applying some voltage here, okay, and let that voltage be V, okay? So what is the voltage drop across resistor? What is voltage drop across resistor? And what is voltage drop across inductor? V.
V.
Why? Voltage in parallel is always same. हमने देखा था ये, right? Voltage in parallel is always same, okay? And then what happens, due to application of this voltage, let us say that some current is getting generated and it is flowing in the circuit. So now I will get divided into 2 points, right? First current, first component, it will flow through resistor, let us call it as IR, and one of the component will flow in the inductor, let us call it as IL, correct? And what is the resistance offered by the inductor? That is again the same, XL, correct? Yes, no? So in this case,
Yes.
what is I? What is I? IR plus IL, but phasor addition, correct? Vector addition होना चाहिए इसका, correct? So I can say I square is nothing but IR square plus IL square, Do you agree with this? So I will be root of IR square. What is IR square? V by R whole square plus IL square will be V by XL whole square, isn't it? Yes, no? So I
Yes,
will
sir.
be V, I can take
Yes, sir.
common. So this will be 1 by R square plus 1 by XL square, isn't it? And then finally I can write V by I, that is equal to Z. V by I, we call it as Z, will be equal to 1 divided by this component, 1 upon R square plus 1 upon XL square. Correct? Yes, no? Yes, do you agree or not?
Yes, sir.
Yeah,
Yes,
complete
Yes, sir.
sir.
mathematics only. Okay. Now can I write from here? So therefore I can write 1 by Z will be equal to root of 1 by R square plus 1 by X L square, and this is called as admittance. Ulta of impedance is called as admittance. Yes. Any problem in this?
No, sir.
ओके.
No, sir.
अभी देखिए इसमें कॉमन क्या है, वोल्टेज है. सो आई विल टेक फेजर डायग्राम. इन फेजर डायग्राम जो कॉमन क्वांटिटी है वो हम साथ में लेते हैं. सो लेट अस से दैट दिस इज द वोल्टेज. ओके. नाउ करंट एंड voltage in a resistor are always in phase. Do you agree with this? So can I say IR will be somewhere here? Yes, no. IR and V, voltage and current in the resistor will be in phase. So let us say that this is IR. Yes, no. Do you agree with this diagram?
Yes, sir.
Okay.
Yes.
What about IL? Now who will say IL? सोच समझ के बताइए. वेरी वेरी कंसेप्चुअल है, आपको तुरंत समझ में आएगा. बताइए.
Stability.
आयल आयल कहाँ पर चाहिए? आयल कहाँ पर चाहिए? आयल कहाँ पर चाहिए? ऊपर चाहिए, नीचे चाहिए, कहाँ पर चाहिए बोलते हैं? देखिए, वोल्टेज एंड करंट इन द इंडक्टर. वोल्टेज लीड्स करंट बाय 90 डिग्री इन द इंडक्टर. करेक्ट. तो वोल्टेज को अगर हमें लीड करवाना है तो करंट इन द इंडक्टर विल बी इन ग्राउंड.
Lagging.
करेक्ट.
Yes.
वेरी गुड. आई एल बराबर है. सो हियर यू कैन से current lags in the inductor by 90 degree or voltage leads in the inductor by 90 degree, isn't it? Yes, no? है
Yes,
ना.
sir.
और हमने अभी तो बताया कि करंट आई आर और आई एल का कौन सा एडिशन है? वेक्टर एडिशन है. सो टोटल करंट इन द सर्किट will be the vector addition of IR and IL, and that is given by this thing. करेक्ट. समझ में आया फेजर डायग्राम? और फिर सबसे इंपॉर्टेंट पॉइंट, व्हाट इज द फाइनल करंट? टोटल करंट आई है, टोटल वोल्टेज भी है. इन दोनों में का जो एंगल है, राइट, उसको हम क्या बोलेंगे? थीटा बोलेंगे. राइट. सो वी विल कॉल इट एज थीटा. एंड थीटा एज यूजुअल इट इज tan इनवर्स ऑफ
P
सीरीज में
by
क्या था?
five.
सीरीज में क्या था? एक्सएल अपॉन आर. यहाँ
R.
पे आर अपॉन एक्सएल उल्टा आ जाएगा यहाँ पर. ओके. यस.
Yes, sir.
एनी प्रॉब्लम इन दिस? ओके. अभी अभी आप मुझे बताइए, पैरेलल का आपको समझ में आएगा? आरसी पैरेलल बोलिए. क्या करूंगा मैं? आर एंड देन पैरेलल विथ कैपेसिटर सी. This is R, this is C, and let us say that I am applying some voltage V. So what will be the voltage across R? V. What is the voltage across C? V. What is the resistance of the capacitor? XC. Right. What is the current flowing in the circuit? Let us say I is the current, so it will get divided into two parts. First component will flow through R, IR. Second component will flow through capacitor, that is IC, and I is nothing but IR plus IC, right? But you have to write compulsory. What is this? This is nothing but phasor addition of vector addition, right? Or you can simply write I is nothing but root of IR square plus IC square, right? And in the same way, if you go, right, I will be equal to V. रूट ऑफ, बोलिए क्या लिख सकता हूं मैं यहाँ पर, 1/r² प्लस 1/xc का होल स्क्वायर, करेक्ट। सो देयरफॉर यहाँ पर 1/z क्या आएगा, रूट ऑफ, सॉरी, yes, correct, no? Root of 1 by z, or we can call it as admittance, right? It will be 1 by r square plus 1 by xc whole square, is it? Yes, no? समझ में आ रहा है?
Yes, sir.
Okay, okay,
Yes, sir.
okay. And then, now you came to this conclusion. So finally, I can write here in a simple words. We can draw the phasor diagram, right? So let us say that what is the common quantity? What is common in all? Voltage V, right? Because voltage in parallel is same. We know this thing, correct? यहाँ पर voltage है V, यहाँ पर भी voltage है V. So voltage in parallel is same. Now just tell me about the current IR. IR कहाँ पर रहेगा? IR will be, yes,
ऊपर
ऊपर, ऊपर रहेगा IR. IR तो यहीं पे रहेगा ना, because voltage and current in the resistor are always in phase. Yes, no? है ना?
Yes, sir.
ओके चलिए, अभी नेक्स्ट इम्पोर्टेंट ध्यान दे के बोलिए, वीसी, वीसी सॉरी आईसी, आईसी कहाँ पर रहेगा? करंट लीड्स वोल्टेज
Leads
90 डिग्री, तो कहाँ पर आएगा? ऊपर आएगा,
upper.
राइट। एंड दिस इज योर वी वोल्टेज अक्रॉस कैपेसिटर, राइट। एंड सॉरी, दिस इज नॉट वोल्टेज अक्रॉस कैपेसिटर, दिस इज करंट अक्रॉस कैपेसिटर। एंड देन फाइनली वी वांट आई, सो आई इज नथिंग बट, पहले ही बोल दिया था मैंने क्या है आई, it is nothing but phasor addition, or you can say, which addition you can say? Yes, कौन सा addition है?
वेक्टर एडिशन
Vector addition, right? So you can always use triangular law or diagonal law for vector addition, and this is your I. And then what is the total angle between the voltage and current? This is phi, and phi you can say, what is phi? Tan inverse of r
आर
by
बाय
x, बराबर है ना? Yes, no?
यस सर
Simple है? Is
Yes,
it
sir.
simple? Yes. So that's unit number, you can say 6 for you. So let me just complete this thing. So we have completed our things simple, right? So we have completed yesterday till RLC circuit, right? And then we will just we have seen today simple RL circuit, right? So in RL circuit, can you correlate this thing? I is nothing but IR plus IL, which we have seen just now. Can you see this thing? Yes, no?
Yes,
Yes.
sir.
Okay. And then, if you go after that, then we have also seen this thing. Maybe I can put it in PPT mode. Okay. So, yes, we can see this thing, isn't it? Right? Phi is nothing but R upon XL, or you can write R upon omega L. Right? And this derivation we have completed. Z is nothing but 1 by root of 1 by R square plus XL square. Is it? Yes.
Yes, sir.
Yes, sir.
And then, you can say that current is nothing but phasor sum of IR and IC. Of course, you can write it anytime. And finally, you can just say it that we can solve a simple, RC circuit. Again, the same thing we have seen. Yes, no? So this phasor diagram again we have seen, and we have seen that IC and IR दोनों का जो vector addition होता है वो R होता है, right? Yes. And again here phi is nothing but, yes, R upon XC, or you can write IC upon IR. Okay, not a problem. Yes, no?
Yes, sir.
And then, here there is a simple problem for you, that a circuit consists of a resistor is given in parallel with C value is there, right? And it is connected to 230 volts 50 hertz supply. So can you calculate XC? Yes. So find the branch current and supply current, right? सुनिए, branch current आपको वोल्टेज दिया है, इसके अक्रॉस वोल्टेज दिया है, राइट? ये रेजिस्टेंस पता है, ये वोल्टेज पता है. सो ओम्स लॉ से आप IR कैलकुलेट कर सकते हो.
Yes, sir.
So we have calculated IR, right? Now you have you want to calculate IC. So what is given? Again, voltage is given. What is voltage? 230 volts. But what is the what is the resistance of the capacitor? XC. Can you find XC? 1 upon 2 pi FC. Right? You have the value of capacitor. You have the value of frequency F. So can you calculate F XC? Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. आपको देखिए इसके अक्रॉस वोल्टेज पता है, रेजिस्टेंस पता है, तो आईसी तो आप आराम से कैलकुलेट कर ही सकते हो, है ना?
Yes, sir.
एक बार आईसी मिल गया तो फिर टोटल आई क्या है? फेजर एडिशन ऑफ आईआर एंड आईसी. अभी जो कंसेप्ट हमने सीखा अप्लाई कर दिया, करेक्ट?
Yes, sir.
और फिर आपको करंट और वोल्टेज में का क्या चाहिए? आपको एंगल चाहिए, तो हमें पता है फाई इज नथिंग बट tan इनवर्स ऑफ r upon xc.
RFXC.
Yeah, so you can get this angle tan. वही फॉर्मूला यूज कीजिए अपना tan इनवर्स वाला. That is also work. This will also work, not a problem. Okay, ठीक है. Okay, and finally, if you want to find the impedance, do V upon R. Correct? Yes. Is it simple?
Yes.
Yes, sir.
Okay, great. Now one last component which I want to cover in the today's lecture, and that is, that will be, we will deal with that component maybe if you come in electronics. So in second year we will be looking more towards the power triangle, right? But as of now, I will just go through that power triangle, and yes. So all these are nothing but parallel admittance, right? So parallel admittance, you can just see it once. Okay. Now this is power and voltages. Okay, so simple. If RLC is in the series, can you correlate this diagram? Can you correlate this diagram? Voltage in R, current in I, in phase. Voltage in L is there in RL circuit. This is the case, isn't it? Yes, no?
Yes, sir.
Yes, sir.
Yes.
Okay, okay. Now just I will just give you some component, right? So let us suppose this is triangle. Okay, what is the length of this side? This is VS, correct? Yes. Okay, now if this is VS, I want to calculate VR from VS. So can I write it as VS into cos phi is nothing but this side, correct?
Yes, sir.
And this side will be Vs into
Sign
sin phi, correct? Yes, no? So this thing we know. Yes, no? Do you agree with this power?
Yes, sir.
Okay.
Yes.
Now what I will do, I will just multiply all the sides by current I. चलेगा? Current से कर सकता हूँ multiply?
Yes, sir.
Yes, sir.
Okay. तो current से अगर multiply किया, तो what is I into V? What is I into V?
Power.
Correct? What is I into V? Power. What is I into V? Power. समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
Okay, so this power, this total power is phasor addition of this power and this power, correct? समझ में आ रहा है? चलो मैं बोलता हूँ, ये पावर जो है, ये this power and this power, there are two powers, right? This is also power, this is also power, and this is also power, right? So this power, right, is phasor addition of this power plus this power. Okay, from the diagram आप बोल सकते हो yes or no?
Yes, sir.
Yes, sir. Yes, sir.
चलिए चलिए मैं आपको और थोड़ा इजी कर देता हूँ. ये पावर, व्हाट इज दिस VR? तो ये पावर किसके वजह से आ रहा है? रजिस्टर की वजह से, राइट?
Yes, sir.
सो दिस पावर VI इंटू V इंटू कॉस थीटा, ये जो पावर है, राइट, दिस पावर इज कॉल्ड एज एक्टिव और रेजिस्टिव पावर. क्या बोलेंगे इसको? रियल नहीं तो एक्टिव पावर. क्यों? क्योंकि रेजिस्टर में पावर क्या होता है? डिसिपेट होता है, करेक्ट? यस।
Yes, sir.
Yes, sir.
ओके।
Yes, sir.
सो इस रजिस्टर में जो पावर होता है उसको क्या बोलेंगे, एक्टिव पावर बोलेंगे, क्योंकि वो सही में डिसिपेट होता है। ओके। ये जो पावर है कौन सा, ये वाला पावर वी आई साइन फाइ, तो ये वाला कंपोनेंट कौन सा है, ये वाला कंपोनेंट किसके पैरेलल में है, इसके, ये वाला कौन सा कंपोनेंट है।
Inductor.
सो कैन आई से दिस इज द पावर विच इज लॉस्ट इन द इंडक्टर, राइट।
Yes, sir.
इंडक्टर में
Yes.
रेजिस्टेंस को रिएक्टेंस बोलते हैं।
Yes, sir.
सो इस पावर को क्या बोलेंगे हम, रिएक्टिव पावर। वी आई साइन थीटा को क्या बोलेंगे, रिएक्टिव पावर। व्हाई रिएक्टिव पावर, पावर इज गेटिंग स्टोर्ड इन द इंडक्टर, इट इज नॉट गेटिंग डिसिपेटेड, इट इज गेटिंग स्टोर्ड। समझ में आया।
Yes, sir.
Yes, sir.
And then what is total power of the circuit, active power plus reactive power, that is nothing but the total power, that is vi. Getting?
Yes, sir.
Yes.
Yes, sir.
Okay, okay, great. So I expect that this thing you are getting. Okay. And yes, there is one more slide which you will not understand, and that is your previous slide, right? That is parallel admittance. Okay, so parallel admittance मतलब क्या है, सुनिए, it's very simple, right? J के terms आपके syllabus में नहीं है, but only in this slide they have introduced. Okay, but yes, if you want to find here R and XL that are in parallel, so can you find the admittance? Yes, admittance is, इसका admittance क्या रहेगा, इसका admittance रहेगा, sorry, इसका admittance क्या रहेगा, ये वाले circuit का admittance क्या रहेगा, 1 by Z, right? And what is 1 by Z, root of 1 by R square plus 1 by XL square. ये फॉर्मूला आप याद में रखिए। इज इट करेक्ट फॉर्मूला, यही हमने सीखा था ना।
Yes, sir.
एंड
Yes.
इन्होंने सिर्फ क्या किया है, इन्होंने ये एडमिटेंस को डिनोट किया है y से, right? And they have told that this admittance is 1 by r minus j by xc, but finally you know, if you take, this is the which quantity you can say, this is complex numbers, right? And if you want to find the magnitude of the complex number, again it will come down to same thing, yes, no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Correct. So you only remember the formula which I have given to you. Okay, don't consider about this j and all that terms, because that is not a means expected for you. It will be covered in proper format, okay, in the second year. Similarly, can you write the same thing for this 1 by z? Just 1 second, okay. Yes, am I audible?
Yes, sir.
Okay, so similarly, I can write
Yes,
here
sir.
admittance is nothing but 1 by z is equal to 1 by r square plus 1 by xc whole square, correct? And this is again derived from the same thing, same logic. Yes, yes or no?
Yes,
Yes.
sir.
Yes, sir.
So can I say that today I have shown you this thing, right? This is RL in parallel and RC in parallel. Was it simple?
Yes, sir.
Yes.
Yes.
Okay. So this was unit number 6 for you. Any difficulty, anyone, you can just ask me. Any difficulty, anyone? Hello, guys. No difficulty, no one? Okay.
So, excuse me, sir.
Huh? Yes.
So, in your PDF that you gave to us, there is a generation of three-phase EMF.
हाँ, that ना, चलो आपको बता दूं मैं, generation of three phase.
Yes,
That,
sir.
हाँ, see, yes. That I was supposed to give you a video. Okay, so I will stop sharing and I will start one more time. Are you getting?
Yes, sir.
Okay.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be looking at three-phase electricity. Now this follows on from our series on electrical engineering, so if you haven't watched the previous videos on this so far, then please do this first. Links are in the video description below. Coming up, we're going to be looking at how a simple AC generator works, then we'll look at a single-phase power, then two-phase power, and then finally three-phase power, as well as how three-phase power is used and why, also why we don't use 4, 5, 6-phase, etc. power. So first of all, let's start with a simple AC generator. We'll start with a single phase to understand what's happening, and then we'll add in other phases until we get to three phases. Let's take a copper wire and wrap it into two coils, then place these coils opposite each other within a stator and connect the ends together to create a complete circuit. Now, if we place a magnet in between these coils and we start to rotate the magnet, then the magnetic field will disturb the free electrons within the copper wire and an electrical current will begin to flow. We've covered how the free electrons flow in our previous video on electricity basics, so please check that out if you've not done so already. Links are in the video description below. As the magnet rotates, so does the polarity of the magnetic field. As you can see in the illustration, the north and south pole of the magnet are rotating, and as they rotate, they pass across the coils, which force the electrons to move. Notice the lines of the magnetic field are in these oval shapes on each side, and they meet through the central axis of the magnet. You can think of these as one side being positive and the other side being negative, and in between these ovals, the magnetic field is neutral. You can see that the intensity of the magnetic field increases on either side until the center, where it is at its maximum strength, and then it decreases again until it gets back to the neutral point. So as this field rotates through the coil will experience an increasing intensity of the magnetic field's positive half, and during this increase, the free electrons within the copper coil will be pushed and begin to move faster and faster in one direction up until it reaches the maximum point of the magnetic field. Then, as the magnetic field decreases, the flow of electrons will begin to slow all the way until it reaches the neutral point where no electrons will flow. Then comes the negative side of the magnetic field, and as this passes through, it's going to pull the free electrons backwards. Again, the flow of electrons will flow faster and faster up until the maximum point of the magnetic field, and then it will decrease back to the neutral point. This is why AC electricity is called alternating current, because the current of electrons alternates in direction backwards and forwards, just like the tide of the sea. If we were to plot on a graph the speed of the electrons flowing during the rotation, then we would get a sine wave pattern. In this sine wave, you can see that the electrons are stationary at the start in the neutral zone, and then the speed increases through the positive half all the way up to the maximum, and then it begins to decrease all the way back down to the neutral, where no electrons will flow again. After this comes the negative half, where the electrons speed up to the maximum point, and then they begin to slow down again until the magnet has completed one full rotation, where this will then repeat. This complete rotation is known as a cycle, and the number of cycles per second is called the frequency, which is measured in hertz. You've probably seen 50 Hz or 60 Hz written on your electrical goods. This means that the generator of the power station is completing a full rotation either 50 or 60 times per second. So the direction of the current is therefore also changing 50 or 60 times per second also. When it is written on electrical products, this is just telling the user what type of electricity the product should be connected to. Now, coming back to the sine wave that we saw earlier, this plot of current also represents power, and if we connect a lamp into the circuit, we'll see that it will increase in brightness all the way to the peak, that maximum point, then it decreases in brightness all the way down until the neutral point where the lamp is actually off because no current is flowing. But then it will increase in brightness again as the negative half of the cycle comes through and the electrons start to flow back through in the opposite direction until again it reaches the neutral point. So, at these points in the cycle, the lamp is not producing any light. And at these points in the cycle, the lamp is not very bright, so it's not of much use. So if you're working in a room and this lighting is flickering like this, it's going to get really annoying. To improve this, we can add another set of coils or a second phase into the generator. And we can do this by placing the coils 120 degrees rotation from the first set of coils and then connect this up to another lamp. This rotation means that the coils will experience the changing intensity of the magnetic field at different points in time. The first coil reaches its maximum current and brightness, and as it decreases, the second coil will begin to increase. This has improved the lighting, but there's still a gap which will cause a flicker. So we can add in a third set of coils or a third phase, and this will mean that one of the lamps are almost always at its maximum brightness, so the lighting is nearly constant. There are still some small gaps between the phases, and you could keep adding more and more phases to fill these gaps, but this will become more and more expensive to keep running all these cables. So three phase became widely accepted as it's a good compromise between power provided and cost to build. Now in the real world, you're not going to use three different lamps on different phases to create lighting. The lamps in your homes are all on single phase, but they are flickering. It's just that they are turning on and off so fast that the human eye can't see it unless you record the lamp in slow motion. A more practical application is to power electrical induction motors and other commercial and industrial equipment, as three phase will provide a lot more power to these items, meaning you can pump water higher or you can run motors faster, etc, etc.
Okay, so you got some idea? Yeah. So basically, the difference is only that in single phase we are getting one sine wave, right? But if we try to put a lamp on it, what happens? You know, the intensity here, the lamp will be more brighter, and here the lamp will get off. Again, here it will be more brighter. Here it will get off. Correct? Yes. No.
Yes, sir.
So that's why what happened after 60 degrees, they are producing another wave, right? And again after 60 degrees they are producing one more wave, right? So what happens, you know, if you find out the average, then at a single point, right, if you add the three waveforms, you will get some a considerable amount of voltage across the lamp, so that lamp will get a good power enough, right? So that's why this three-phase circuit comes in the picture. Is it clear? Yes.
Yes, sir.
Yes,
Yeah, so that slide is only to give you an idea that what is three phase. क्योंकि हम बोलते रहते हैं ना कि what is three phase, what is single phase. That is okay. Done. Yes, no.
Yes, sir.
Yes, sir.
Okay, Anirudh, recording stop किया कर दो है ना. Okay, so please give me the attention.